In this problem, we want to determine how much of a moment is produced by this force, but specifically in the direction of AB, which is about that AB axis there, okay? So in order to figure out basically the component of the moment about the axis AB, we have to take the moment and dot it with the unit vector along the line of action of AB. Okay, now I can take the moment from anywhere along the axis AB, from that point to anywhere along the line of action of the force. And the easiest way to do that is to take my R vector from B to C as shown here. So I'm going to take the moment about B in order to get that. So I need to find RBC. That's my moment arm going from the axis to the force, and it's the simplest one, and it's just 4K. Okay. Then I need to take that R vector, cross it with the force vector shown here. Okay. And I'll let you do that on your own. But when I do that cross product, I get negative 40I minus 80j, whether you use a calculator, a determinant, right-hand rule, whatever you want to use to get that. That is what the moment about point B is. Now that I have the moment about B, again, I want to know how much of this moment is in the AB direction, right? Just like I would say how much is in the I direction, I'd say negative 40. I'd say how much is in the J direction, I'd say negative 80. My question is how much of this is in the AB direction? So what I do is I dot this with my unit vector from A to B, which is going to be the position vector over its magnitude, which will be 3I plus 4J, okay? And again, this is the unit vector from A to B, so that's that position vector. Now, square root of the sum of the squares, this is a 3, 4, 5 triangle, essentially. And I get my unit vector to be 0.6I plus 0.8J. And again, this is a unit vector as a magnitude of 1, okay? I'm going to multiply my moment, I'm going to dot my moment with this unit vector to figure out how much of that moment is in the AB direction. Okay, so and that gives me, again, the magnitude of the moment in the AB direction. So I'm going to take I times I, so that's going to be negative 40 times 0.6, plus J times J, which is going to be negative 80 times 0.8. And of course, none of this is in the K direction, so I don't need to worry about it. From this, I get an answer of negative 88. Why negative? Well, that's telling me that my vector is, how am I, best way to do this? That vector is actually going that way around the pipe. As I pull on that, it's creating a moment about the AB pipe in that direction, which of course looks like that when I draw a moment vector, which is not the unit vector A to B, it's actually B to A. So that's why the negative comes from. I'm looking for a magnitude here anyway, so I can just call it 88 Newton meters. Okay, so in order to find how much of a vector is in a specific direction, I just take that vector and I dot it with a unit vector in the direction of interest.